how to measure the pixel size in an image. And the outline for this tutorial is first, why do you want to measure the pixel size? What you need to do it. And finally, I'm going to show you how to do it in two programs. One is ImageJ and the other one is Murek. And the reason why you want to know the pixel size is, for one side, you maybe want to do dimensional measurements, knowing the size of different items in your images, if it's tomography or if it's just radiography. Anyway, you want to know the size of the object with the aim to quantify information in the images you measure, because otherwise you only do nice pictures. And the aim of most scientific imaging is you want to quantify the results. The other reason is to quantify the attenuation coefficients, in particular for tomography. The attenuation coefficient is actually scaled by the pixel size. So if you get the pixel size wrong, you will actually do a misreading in the quantified information. So for example, you want to measure the amount of water in tomography data. That would already give an error if you get the pixel size wrong. There are other causes for the errors, but at least you can get the pixel size right. So let's go on and look at how you can measure it. And first you need items in the image which have known dimensions. So you have to actually measure it before, or you have to know the exact size from the manufacturer. The other thing is you have to count the number of pixels between 2 points in image. So down here you can see two different kinds of objects. One is the edge object from the IAEA test sample box, which some of you maybe already have seen. And this item here has a size 15 millimeters. So this is a very good starting point. The other one is to use a test pattern. And in this test pattern, you have a centimeter between each of these boxes, which also gives you a good dimensional measurement. Typically, you want to measure over as many boxes as possible. Then the pixel error is reduced. And once you have the pixel size, you can once you have the number of pixels, you can determine the pixel size as the length of the item divided by the number of pixels along this item. So let's take a look at how you do this in ImageJ, and let's move to the other side. So, and first we need some images, and ImageJ is already started. So in here I have 3 images. Let's start with the edge, which we have here. Maybe we can also adjust the contrast and brightness a little bit. Not necessary, but it looks better. Then the next thing you have to do is to take the line measurement tool, and here you have to try to find a good spot and drag this line to the other side. Well, that's not really perfect, so let's go, yeah, maybe something like this. Now we have the length of this object, and the next step is to go to Analyze, and here you can go to Set Scale, and then you get the distance in pixels of this yellow line, and you have to enter the known distance, which is 15 millimeters. You can even make a nice change here saying that it's millimeter. Now for ImageJ, they usually measure it in pixels per millimeter, and what you normally like to do is actually having the inverse. So that would be millimeters per pixel. So let's take the calculator. Let's see, here it is. And then we have to type in here 30.97. And we also, actually, I need to change the view to scientific. And now I just take the inverse, and then we know now that in this case the pixel size was 32 microns. So that finishes the measurement in ImageJ. You can use it for the purpose you need. The other way to do it is to do it in Murek. Let's just close these windows, and let's take Murek, which we already have used in a different tutorial. And here you can go to the reconstruction geometry tab and measure pixel size. And in here you have to browse for the image. Let's go for the desktop, pixel size, the edge, and open. It's opened. And here you just mark a box like this. Click get, it turns red. And then you have to select which kind of feature you want to analyze. And in this case, it's an edge. And you have to enter the known distance, which is 15 millimeters. And then you press analyze. And then you can get the distance in pixels and also the pixel size, which is more or less what we also got with ImageJ. The difference here is if you look at this image here, you have a green line and a yellow line. So what this little widget is doing is actually to identify where you have the edge lines, and then it computes the shortest distance between these two, hopefully parallel lines. And with that, you get a more accurate and reproducible result than if you try to drag an ImageJ, try to drag along and see where it is. So you can be pretty imprecise in where you select the box, but afterwards it finds it. Just as a demonstration, I can also actually take from this edge to this edge, and that should even find two other edges. So here you get from that to that edge, and to be correct, it's actually 30 millimeters. So let's press analyze, and you get 32 point, not exactly the same value, but again 32 microns approximately. Now I showed you another type of image, and that was the test pattern. And let's load it. And here you don't have any strong objects, but you have a lot of lines. So instead, you can now just select a certain number of lines. So let's take 1, 2, 3, 4, 5, 6, 7, 8, 9, for example. Press get, and now you have to select lines instead, and it was 9 boxes, so it's 90 millimeters, and then you can press analyze. And well, in this case, these objects were not that precise apparently, so we have to get a little bit better, sharper lines. Let's take those here. Now we have 4 boxes, and then it didn't find it either. So you can see that the line analysis require much sharper objects. So maybe it's better to work actually with the strong edges of a solid box. So for example, like this one, and that would be 10 millimeters. And no, it was like this. So yeah, this image seems to be not so clear as it should be, but if you have a much sharper image, you can actually do it better with that one. And once you got your dimensions, actually go back to this one and mark up the edges, its edges already, and it was 15 millimeters, and analyze. Then when you press OK here, you get the pixel size already in this box. So it's a quicker way actually than to do it outside in ImageJ if you want to do a reconstruction. And well, that is the end of this tutorial.